So we are going to review some of the questions from 2024 chapter sprint run. So the product of three consecutive multiples of 5 is given. Then we want to find the list of these three numbers. So this was a number 21. So and then we want to kind of do it without a calculator. So since this is sprint. So it says the multiple of 5. You know, if there's a number that is multiple of 5, so let's call this is like 5x. Then the next number should be like 5x plus 5, which I can write it like, let me just write it. So 5x plus 5, because that's just the next multiple of 5. And the next number that is a multiple of 5 is going to be 5x plus 10, because they are increasing by 5 every time. So that is given as 42k. So if I see like this is like divisible by 5, this is divisible by 5, I can pull the 5s. So that will be 5 to the third power times x times the middle one will be x plus 1. And then this is x plus 2. And that will be 6 times 7. And then this is times 1,000. So 5 cubed is 125. If you divide by 125, this is going to be 8. So which is really, we got nicer because, you know, this was x plus 1, x plus 2, and x. They're increasing by 1, so 6, 7, and 8. So the x should be 6, right? So this is something we have already. But the question was asking us to find the list of these numbers. So the list of these numbers is 5x, not just the x. So that is why the answer is going to be 30. So you can confirm by multiplying if you need to. But this is number 21, so that wasn't too bad. So let's look at the next one. So number 22, so we have someone who has all the positive integer less than 2023. So I'm going to name this as A. So 1, 2, or 3, all the way to the 2022. And then another person, Beth, is adding the even positive integers. So I'm going to name this as the sum is B. So we are going to just add the even numbers. So you will get like a 4, 6, all the way to the 22. And what we want is the remainder when you divide the absolute difference between these two sums by 8,000. So you can just go ahead and add them. Like some of you already know the Gauss formula for this guy, which I will probably do as our first shot. So if you want to find the sum of these numbers, and then you can subtract the sum of these numbers and then see the difference. Like this can be written like as like maybe instead of doing this, I can just like I can use Gauss formula for sure. So the Gauss formula will tell us the sum of the first n integer is going to be the last number, which is 2022 times one more of this, which is 2023 divided by 2, which is n times n plus 1 over 2. And for the second sum, since everything is even, so I'm going to pull the 2. So that will give us like 1, 2, 3, all the way to the 1011. So now this is the sum of the integers that is increasing by 1. So I can use the Gauss formula now in this case. So the 1001 times 1002 over 2. So this is the first sum. This is the second sum. So I can clean these. So the second sum is going to be 1011 times, this is 1012. And then the first one, if I divide by 2, so you will get 1011 times 2023. So what we want is the layer difference since A is larger than B. So I can just do this way. So the 1011 times 2023 minus 1011 times 1012. And since we have 1011 common, so we can pull that 1011. So that will be 2023 minus 1012. So if we subtract 1000 from 2000, that's just 1000 left. 23 minus 12 is 11. So that should be 1011 times 1011. So at this point, if you are looking for the remainder when you divide by 1000, you can just multiply 1000 by 1011 by 1011 and look at the last 3 digits, which gives the answer. But instead of doing this, we can just like use the modular arithmetic, which basically I can take the mod 1000. So if you divide 1000 by 1000, the remainder will be 11. So the 1011 is congruent to 11, and the same thing as this number. So that is mod 1000. So if you multiply 11 by 11, that's 121, and that will be our remainder. So you can do it this way, which is not too challenging, to be honest, for the number 22. And you can even make a, I will say, like formula, like for the odd ones, because if you look at the list A again, so that's 1, 2, 3, 4, all the way to the, let's say, 20, 20, 20, 21, 20, 22. And then the B was like 2, 4, all the even numbers. And then if you want to find the difference between these two, so the evens will be gone. So you will get like these will be gone, these will be gone. So these will be gone, these will be gone. So you will just get 1, like 3, 5, all the way to the 20, 21, which is just the odd numbers. And some of you may know this, some of the odd numbers like is like 1, like 3, 5, all the way to the like 2n minus 1, because the odd numbers can be written as 2n minus 1, and this is equal to n squared. So in this case, we have n numbers. So if you plug n equals 1, so you get the first term, n equals 2, you got 2 for the 2n minus 1. And if I take n 2n minus 1 as a general term, so if you plug n for n, so you will get the last term. So the sum of these numbers is n squared. If you don't know why this is the case, then it's good to remember, like review as well. So in our case, the last number is 20, 21. This has to be our 2n minus 1 term, which is the odd term. So that means 2n will be 20, 22. The n would be just 1011. So meaning that there are 1011 like terms in this list. You can even count that easily without really using this approach. If you have 1011, the sum of the 1011 odd numbers is 1011 squared, and then we want to say what will be the remainder when you divide by 1000. So, and then that's the same as before. If you take the 1011 as 11, because that's the remainder is 11 when you divide by 1000, so that should be 11 squared is congruent to x mod 1000. And you can just say this is under 21 as well. And here's my challenge. Like I just kind of did 2 different ways, but the third way, you may find a general like expression for the A and then general expression for B, and then take the difference between those 2 general forms and find a nice, I would say, expression, which is gonna be something similar to this one. And you can use that as your another approach as well. I'm gonna leave that for the challenge, okay? So let's look at the next one. Number 23, we are given a regular hexagon. Okay, so let's highlight this one. And the person connects the midpoints of the sides of the first hexagon to form another hexagon. So these are the midpoints basically. And what is the ratio of the smaller one to the larger hexagon, basically? Okay, so like just to remember, like whenever you have a regular hexagon, and then you can just connect the center of the hexagon to each vertices. If you do this, you will get 6 equilateral triangle. Okay, so and then if you do the same thing with the other the larger one, you do get similar as well. So I don't really need it, but just to show you how that looks like, you can just take this, like say the center point, and connect this vertex and then this vertex, and this triangle will be one of those equal triangles in the larger one. So the goal is just to find the ratio of the one of the smaller triangles, which is in red, to the area of this the blue one. Okay, so what we know is, since this is a midpoint, I'm gonna, like, I can use just the numbers if I want to, but I'm gonna go with nx and x. So that will be x and that will be x. And since this is a regular hexagon, if you divide 360 by 6, and like you will get 60 degrees, which will be exterior angle. Okay. And if you subtract this from 180, you get interior, which means the inside angle right here is 120. And some of you already know n minus like 2 times 180 is the sum of the interior angles. And then if you divide this by n, you get 1 interior. So you can just kind of go with that as well. So like n is in this case 6, so 6 minus 2 is 4. 4 times 180 over 6. So that will be 30 times 4, which is 120. That's what we already got it. So by using exterior, but I like this approach instead of this one. So we know the exterior, like interior angle is 120, and then there's isosceles triangle. And just remember, like this side is 2x. And there is a formula for the area of the equilateral triangle, which is s squared times root 3 over 4. So I hope you already know this one, because if you are doing MATHCOUNTS, so you should really know this one for sure. To make a bit quicker. So the area of this triangle, the blue one, is going to be the 2x times 2x, which is the square of the 2x, because that's the side, times root 3 divided by 4. So this is the area of the larger triangle. And then what we want is the ratio of the smaller one to this one. So the smaller one is this red one. So to do so, we need to find one side of this triangle. So you can kind of see it. There is a triangle going on right here. So you can connect this one, because this will be 90 degrees. And if you were to connect this one, that will be 60 and 60 split it. So that will be 30, 60, 90. So maybe I should show that anyway. So if I connect this point, so you will get a 30, 60, 90 triangle right here. So the 30 degrees is opposite x, so that means this side will be x root 3. And just a quick reminder, so you've probably seen a lot of nice relations, but if you have a triangle where this is 120, and then this is 30 degrees, this is 30 degrees, which is we have right here. And if these are the x and x, this side will be x times root 3. If you like remembering some stuff, this is also another one to remember. And if you don't, so you can just extend and make it 30, 90 degrees and go from there. But that might be useful, because if you remember that, so you can just get this side immediately without really drawing this anyway. So now one side is x root 3. So we are going to say x root 3 like square, x root 3 square over times 3 over 4. So this is what we are looking for. But at the same time, you see that this doesn't really matter, because they will cancel. This doesn't really matter, they will cancel. And then this is the ratio to one of those 6 equilateral triangle. But since we have 6 in both, so if you just multiply by 6 and divide by 6, that will be the same thing, which is why we don't really care. And now the square of this will be 3x squared, and the denominator will be 4x squared, and then x squared will cancel, so you will get 3 over 4. So I kind of did a bit longer. So if you were to do this problem a bit shorter way, here's what you can do as well. So you say this is x and this is x, then the other side is x root 3. So then the ratio is just the x root 3 over 2x. That's the ratio of the two sides. Since this hexagon and the larger one is similar, if this is a ratio of the similarity, then if you square this, you get the area ratios. So that is exactly what we had there. So that is 3, 4. So instead of doing this much work, so you can just go with that, because they are similar. So I guess that is much better. So let's see the number 24. 24, so we have a certain MATHCOUNTS chapter competition, and the top 6 math lead scores are given on the sprint and target, and not necessarily in that same order. The first place is awarded to the math league with the highest combined sprint run and a target scores. So some of you might be confused, because usually when you find these scores for the MATHCOUNTS, you double the score you get from target and add it to the score you get from sprint, and just kind of do that way. But in this problem, they don't really ask that. So it just say highest combined score of these two. So, and then based on this, what is the least possible score for the first math lead? So like if you want to find the highest, then it's kind of obvious because if you add 29 to 16, so assuming that those are the scores that the first person is actually getting, so which is going to be 45. So which means if you have no idea, you can just guess something lesser than 45 because that's the highest you can get possible. And our goal is just to get the first person to have the least number of score possible. So if I want to kind of do such a thing, you probably want to like choose the highest score from screen with some of the lowest from the target. So let's say if I combine these two, so you will get 29 and 10. So that is 39. So which means there might be a score of 39, or if you want to add like 14 with maybe 28, okay, so that would be like a bit higher, but our goal is just to get as small as possible. So which is instead of adding 14 with that, I'm going to add with the smallest possible, which is going to be 38 when I combine these two. So, and these are the two different scores we might have. So 39 might be our best shot, or maybe 40 even. So let's see if there is something much better. So if I add 28 to this guy, so that must be a 40, and then we cannot really do smaller than that because if I want to choose 29 and like 12, we already tried that's 39. And then if I do 29 and 12, which is we have two different 12s, so that would be a bit like more than what we already have. So these are the lowest so far. And if I want to go with now 26 and 12, which is going to be 38, so that's also okay. And then we got 24 and 14 maybe. So that could be 38, and then 23 and 16. So I can, I guess, go with that. If I go with that is 39. So like we can achieve a 40 at least, but I cannot really do lower than that because I have two 39s and then 140 already. If I want to try 39 to be possible, then I'm not going to be able to get another person who has highest as 38 because there are already 338. So there is no way to get 39 as a high score. So we should have a 40 to be highest score for that top at Mathly. Okay. So that was number 24. So the last question I'll do for this case is number 25. This is a straightforward problem, but it just asking you to remember the exterior angle theorem. If you do, that will be make easier. Otherwise, you will get a bit longer approach for sure. So we have this line is parallel to this line, which will tell you the angle right here is the same as this angle. So that is also same as this one. When there are two parallel lines, these are corresponding angles. And when you have a triangle, which is we have right there, two interior angles are add up to exterior of the third interior. So in our case, 11t minus 1 plus 6t minus 6 is equal to 16t plus 1. So because this is interior, this is another interior, when you add two interior, that will be equal to exterior of the third. If you're wondering why, because when you add these two plus this interior, this 3 add up to 180, but these two is also add up to 180. So this angle makes 180 with this angle makes with the 180 with the other two angles. So that means the sum of these two has to be same as this guy. So, and then this has a name that's called exterior angle theorem. So you can just Google it. So you will get 17t minus 7 equals 16t plus 1. Subtract 16t from both sides and then add 7 to both sides. So you got t as 8, and that is the answer. So it wasn't too challenging for number 25, to be honest. It's just angle relation in parallel lines. Okay, so I'll see you in the next video.